Hi everyone, it's Ajanette and I'm here to go over your Chapter 2 lecture, and that's covering the science behind psychology. And so we're first going to talk about why research is important. I know many of us don't aspire to be professional researchers, but it's a really fundamental skill to have in life just so you can make more informed and critically evaluated choices in your life. In general, we have a few different sources of knowledge. We have our own intuition, and that's often flawed and not objective. And, we think based on our own personal experience that we have a really good idea of how the world works, but in reality, we have kind of a biased view of how the world works from our perspective. In reality, when you step outside your own perspective and you look at things much more objectively and critically, you'll realize that there are some flaws in how you approach things, and there might be some alternative explanations that might be more comprehensive, or they might be maybe a better explanation than what you thought your circumstance was. There's also authority where we can trust in the words and wisdom of others, and sadly that can take us down the wrong path as well. And we trust even our teachers, let's say, but our teachers are not always the supreme authority on everything, regardless of what they may think or you may think. It's really important not to put people on a pedestal, yourself included, because again, then we're having a bias and it's kind of a tunnel vision, and we're not recognizing the value of those around us. And so again, we want to look for more objective means of acquiring knowledge, adapting and modifying that knowledge over time. And science provides a really objective way to do that, to build our knowledge base, to critically analyze our existing understanding, and to potentially adapt a new understanding. Hold on just a second. Sorry about that. That was a student. So, science really gives us an objective way of analyzing information. It can help evaluate things aside from our superstitions or intuition, and we really need to do it very objective and critically without any preconceived ideas. And our goal of science is to better understand the world. Sometimes that might allow us to make appropriate changes to improve the quality or standards of living within the world. But it uses an empirical process, which is, as we talked about in the last chapter, an objective, observable process that we can use. And there's tangible evidence that can either support or refute the ideas that we might have in terms of a hypothesis. When we talk about psychological research, we really are talking about research on psychologically related topics, but grounded in that scientific approach. And so we study behavior, cognitions, we study physiology, the biological processes happening, everything that kind of corresponds to the overt behavior that we see on the outside. And what we use the information for is, to investigate the theories that have been proposed, to debate those theories, find alternative explanations. One such debate that's been going on for a significant number of years in research is the influence of aggression in the media and how that might influence violence in society. For instance, children who play more violent video games, they may be more aggressive on the playground. And so, in that sense, we really want to critically understand that relationship, and then maybe that might inform policy and parental choices moving forward. So our psychological research really lets us critically examine issues from multiple perspectives, and there's often these debates that rise up on a given topic where we have just as information that supports it as we might have that negates a particular policy or issue. And so it's really important that you make an informed decision for you on any given topic. Once that research is available, then our politicians may gain access to it, our administrators in public institutions might gain access to it, and they may actually put legislation in place and policies in place that are based on this research. Additionally, Our budgets might be predicated upon it. We might see that, investing such and such X amount of dollars in this as a way of preventing teenage pregnancy is a much more cost-effective and productive solution than maybe investing in something else. So maybe very open and liberal sex education might be a more effective way of reducing the costs associated with teenage pregnancy rather than abstinence-only policy or programs. And so that might influence the policy of the schools in terms of their sex ed courses they make available to students. So our research is really what helps us not only on a policy level, at a fiscal level, but also at a personal level. We can be critical consumers of information. We can thoroughly analyze the research on any given product, medication, service, treatment for our own personal lives. So for example, my cousin had a radical hysterectomy after some challenges arose, and she was still very young in her 30s, and she wanted to get my opinion on hormone replacement therapy, and that's really not something I was comfortable advising her on. Instead, I provided her some research studies for and against hormone replacement therapy so she could make an informed choice for her own body. I don't want to be the person responsible for making that choice. So I think in that sense, using research and relying on primary research where we're reading the article directly from the researcher themselves, it becomes a very powerful tool for helping us make informed decisions that could impact ourselves and our families. So psychological research also helps us really differentiate the difference between facts and opinions. Where facts are, reality, we see empirical evidence that supports those facts, and opinions are judgments, and they're very subjective. They may or may not be accurate, and there's no concrete evidence to really prove one or the other wrong. And I think in life we want to rely more on facts than opinions, particularly as it relates to maybe our medical treatment, our academic pursuits, anything that's requiring a tremendous investment of our time, money, and intellectual and emotional energy. So all science is really based on the scientific method. The same scientific method that you learned about in 3rd grade or 4th grade when you were doing the science fair is the same scientific method we adhere to throughout our lifetime across fields, whether it's biology, physics, psychology, anthropology. It's irrelevant. We all adhere to the same underlying principles of the scientific method. The scientific method allows us to test our ideas against the real world and see whether or not our assumptions are accurate or not. It's very circular and cyclical. Someone conducts a study, they publish it, it inspires someone else to read it. We come up with a research question related to that study. We have a hypothesis. We conduct a study. We affirm or negate our hypothesis or reject or fail to reject our null hypothesis. And then we publish our findings, and then it's picked up by another researcher, and the cycle continues on and on and on. And that allows us to kind of test each other's assumptions. It allows us to test each other's methodology. It allows us to find consistency in results. If I'm getting the same results that you've gotten and the person before you got and the person before you got that, then that makes our results more credible. And so that replication process is fundamental to the concept of science. And again, we propose a hypothesis, we conduct the research, we create or modify theories based on that research. If the research is supporting the theory, then we support it. If the research says, hold on, based on the theory, X should have happened, but instead Y happened, then it helps us to modify the theory or reject a theory and propose a new theory. A theory is really a well-developed set of ideas. It proposes an explanation or for observed phenomenon. So why does something happen the way that it happens? And that's, a theory or set of ideas that help explain why those things occur. It's checked against the real world by way of research and by way of an expectation of what should be happening, assuming the research or assuming the theory is correct or not correct. Sadly, though, theories can be very broad, and because they're so broad, they encompass a lot of information, and they can't all be tested in one research study. So they're quite often broken apart, and they're tested in pieces incrementally. A hypothesis will test a specific aspect of a theory. It's very specific, and it must be presented as a testable prediction. A hypothesis cannot be an opinion. It must be grounded in fact, and I'm predicting the nature and order of the facts, and my research study will either confirm or negate my hypothesis. It's often worded as an if-then statement. If the world is flat, then when I reach the edge of it, I should fall off. If the world is round, then there is no reaching the edge of it, and I will continue in a circular manner. And so I can test that. I can go out into the boat to the edge of the earth, and I can see if I fall off or if I continue on because of its round nature. So in that sense, a hypothesis is falsifiable. I can prove that it was correct or incorrect in this case. So again, we take the theory, we use that theory to form a hypothesis about a specific aspect of the theory, and then our hypothesis is the inspiration for our research study. We design a study that will be able to clearly test that hypothesis, being mindful of holding potential confounds constant, and then we conduct the study, perform the research, gather the data, observe the outcome or results of our treatment, and then based on the statistical analyses, we will then determine our results for the study and create or modify the theory accordingly. So again, it's that circular relationship that happens through a replication. Additionally, scientific approaches require inductive and deductive reasoning. Where inductive reasoning, I'm looking at the empirical observations and they're inducing new ideas about the real world. So I start with empirical observations, and those allow me to go from specific to broad. Or I can do deductive reasoning, where I'm looking at kind of this large generalization, and then I'm deducing things about the world based on that large generalization. So a couple of examples for inductive are you observe that apples, bananas, oranges all grow on trees. That's very specific. And so you assume all fruits grow on trees. So it goes from small to big. And then the deductive is the opposite, where it goes from big to small. Ducks are living things, so I deduce that they need energy to survive, because all living things need energy to survive. And I can test a very specific hypothesis related to that. So typically when we're going from hypothesis to those empirical observations, we're using deductive reasoning. It's deducing, it's going smaller. So it starts big and it's going smaller. Inductive reasoning, I'm starting small with a very specific empirical observation, and then I'm forming a larger general broad hypothesis. So we do have 6 steps involved in this scientific method for every study that's conducted. We start with a literature review, which is reviewing other studies and getting a really good understanding of what we already know about a topic, what the research has already found and established about that topic, what kinds of studies have been done, how they've been done, and again, their results. Based on that, we want to come up with our own research question and formulate a testable hypothesis. We're typically going to predict a hypothesis or an outcome consistent with what the other research has been saying so far. We're going to include very specific operational definitions. If I go back to the discussion about watching media violence influencing aggression in our children, I need to be very specific as to what constitutes violent media. Am I going to look at video games that M-rated? Am I going to look at video games that as children's rated? I'm going to look at kind of how I'm going to specifically define that term. So an operational definition provides an observable, measurable definition. And then I'm going to conduct my research. I'm going to design my study, conduct my research, run my stats, and then I'm going to publish those in a peer-reviewed scientific journal. That's an empirical paper based on direct data collection so it can be replicated and then lead to a theory development. And I'll be back.